In today's lesson, we're going to learn how to convert between moles and liters of gas, and we're going to understand what STP, or standard temperature and pressure, means. So we've already learned in earlier lessons how to calculate moles using atoms and molecules, and grams using Avogadro's number and molar mass. So we do have one more mole conversion factor to learn, and that is dealing with volumes of gases. So what we notice is that 1 mole equals a specific volume of gas at standard temperature and pressure. Standard temperature and pressure, or STP, are specific temperatures and pressures that we use. Specifically, that is 0 degrees Celsius and 1 atmosphere for your pressure, or 101.3 kilopascals, or 760 millimeters of mercury, any of those pressure units that you find on the front page of your reference table. So the actual conversion factor says that 1 mole is equal to 22.4 liters of a gas at STP. What this is telling us is that in exactly 22.4 liters of any gas at that temperature and pressure, there's going to be exactly 1 mole, or 6.02 times 10 to the 23rd atoms or molecules of that gas. And it does not matter what gas it is. The only caveat is the temperature and pressure. Let's look at a couple of examples. So here's our first example. How many moles are in 48.5 liters of hydrogen gas at STP? So just like we do before, we always want to pick out our given and our goal. So in this case, my given is going to be the 48.5 liters of hydrogen gas. And then my goal is going to be moles. So we want to know how many moles are in that volume. So we'll start with our train tracks. Again, always plugging in the given to the top left box. So we have 48.5 liters of hydrogen. And we just learned that at STP, there are 22.4 liters in 1 mole. So I'm going to put the 22.4 liters on the bottom, and that will be equal to 1 mole. Therefore, my liters cancel out. My new unit is moles, and so that's what they asked us for. So I'm going to multiply across the top, multiply across the bottom, and divide. And that we see that that is going to be 2.17 moles of hydrogen. Pause the video and practice example number 2. Now let's take a look and check our answers. What volume does 175.3 grams of H2S gas occupy at STP? Okay, again, looking for our givens and goals. My given, 175.3 grams of H2S. My goal is going to be volume. So this time we need to go from grams to volume. Volume, the unit of volume is going to be liters. So we need to go from grams to liters. Well, there's not one single conversion factor that's going to allow us to do that. So we're going to have to do a 2-step train track. So as usual, let's put our given in the top left box, 175.3 grams of H2S. Now we need to think back to our mole conversion factors. The mole conversion factor that has grams in it is the molar mass. So we know that 1 mole of H2S equals some number of grams. We need to figure out what that is. So if we have 2 hydrogens, that's 2 times 1 for hydrogen, and 1 sulfur is 32.06. So we add that together, and we get 34.06 grams of H2S is equal to 1 mole. That way my grams cancel out and my new unit is moles. That's not what they asked us for though. So we're going to add another train track. This time to go from moles to liters, we're going to say 1 mole of H2S is equal to 22.4 liters, which is the new conversion factor that we learned. Our moles cancel out. My final unit is liters. So I'm going to multiply across the top, multiply across the bottom, and divide. And so we see that that's going to come out to be 115.3 liters of the H2S gas.